Welcome to episode 54 of Silver Lining for Learning. We're excited to have you join us, and we're talking today about immersive virtual reality to teach about climate change and conservation. With us are Kristy Kroeker, who's an associate professor in ecology and evolutionary biology at the University of California, Santa Cruz. Kristy's research examines the ecological effects of climate change and ocean acidification on marine communities and ecosystems. We also have Jeremy Bailenson, who's founder and director of Stanford's Virtual Human Interaction Lab and one of the world's top authorities on immersive interfaces. Jeremy and I have gotten into trouble together for years and really enjoy the different affordances and challenges of immersion. And our third guest is Anna Queiroz, who I've co-presented with before at different kinds of events related to virtual reality. Anna is a postdoctoral researcher at the Jeremy's lab and at the Lehman Center at the Graduate School of Education at Stanford. So our game plan for today is to start off with Kristy to talk about the science that underlies these issues of ocean acidification in particular, but all of the different kinds of threats that we're seeing now to the ocean, which in turn becomes threats to the existence of the human race. And then Jeremy will talk about how the collaboration began and what the vision of VR to enhance this work has been. And then Anna will talk about some of the on-the-ground things that have been happening, but we'll mix it up with questions and so on to keep it from being a panel. So Kristy, I'm going to ask you to start off and tell us about yourself and your work.
Sure. So I am a marine ecologist by training, so I study life in the sea. And when I was in graduate school, I was quite interested in working on issues of climate change. And as I was trying to decide what I would study in particular for my thesis, I stumbled across this issue of ocean acidification. So this was a number of years ago. And ocean acidification is often called the evil twin of climate change. And so what it is that the oceans actually absorb carbon dioxide from the atmosphere. In that, as it absorbs into the ocean, it reacts with the seawater, and it causes a series of really predictable changes in the chemistry of the ocean, which makes it harder for organisms to build their shells or skeleton. It makes it harder for animals to maintain their kind of correct physiological balance, and can cause really dramatic shifts in communities and ecosystems. But at the time that I started reading about this, it was very new concept. So people were still talking about, wow, there's this thing happening that originally we thought was a good thing because it's actually slowing climate change. It's taking carbon dioxide out of the atmosphere that drives climate change. But now we're realizing, oh, it causes these chemical changes in the ocean. And so people had just started to do some experiments to look at what that meant for, say, a coral or for a mussel or an oyster. And they would take these organisms and put them into an experimental aquaria where they bubbled carbon dioxide into the water and created these ocean acidification conditions that they thought would occur in the near future. I am a community ecologist, and so I was interested, well, what does this mean for the ocean writ large? What does this mean in an ecosystem? And so I put on my most creative thinking and found these volcanic carbon dioxide vents that were off the coast of Italy. And these are naturally occurring vents that are in very shallow water. So they're in about 10 to 15 feet of water. They're not deep sea hydrothermal vents. People often think that when I say I worked on carbon dioxide vents. They're shallow water vents that release carbon dioxide into the coastal ocean, and it just kind of bubbles up. It's kind of like being in a glass of champagne or in a cold hot tub. So there's no temperature associated with them. It's just carbon dioxide and a trace amount of a few other gases, but really like 90 to 95% carbon dioxide. And so it's essentially these natural laboratories to understand how an entire reef might be affected by ocean acidification in the future. I spent a good part of the last 10 years working on these carbon dioxide vents and trying to describe what happens to the reef ecosystems and the species that live in these reefs. And it's been really compelling research. I can tell you a little bit about what does happen if you're interested. But what was most compelling about this research is that it's a really, really striking visual system where ocean acidification is slow. It's happening over the next, it's already occurring, but it's going to just continue and accelerate over the next 100 years or so. And you look out at our big blue ocean and it's beautiful. You don't actually see the carbon dioxide being absorbed or these slow changes that might affect our ecosystems. But I got the opportunity to work at this vent ecosystem where you could swim in 150 yards or meters from an area that had no carbon dioxide bubbling, so no effects of acidification, into these zones with more and more carbon dioxide bubbling that were representative of what we thought the ocean might look like in the year 2100 or in the year 2500. So they essentially served as a crystal ball for being able to look into the future and say, okay, this is what we think the coastal ocean might look like in 100 years or 400 years if we continue to emit carbon dioxide emissions at the same rate. So that was the research that I've done for the last 10 years. And then I've branched out from there to really just continue thinking about how do we improve our understanding of what these changes might be. And then is there anything that we can do to actually slow them or help communities adapt to the changes?
Well, this is fascinating. And I'm not an ecosystem scientist, but I've developed with my team curricula in ecosystem science. And one of the things we emphasize in the curricula is that this is not like physics and chemistry where you can do highly controlled experiments. You can't divide a pond in two and do something awful to half of the pond. So having this naturalistic phenomenon that's essentially a time machine must be really, really interesting because there's a gradient, right? Of the carbon dioxide.
Yep. Yeah, you can essentially swim through time into the future, what we think the future will look like if we continue to emit carbon dioxide concentrations. And yeah, it's really hard to do the biology. It is, I don't know, there have been a couple massive experiments that have tried to recreate ecosystems in a lab setting where we can actually manipulate them. But even those are hard to do. We can't rebuild an ecosystem very well. So everything we do in the lab is really limited. And having a field system like this that is so visually striking has been really interesting and powerful.
So under Kurt's leadership primarily, but with the help of all of us, we've had a series of episodes that have been about the environment in different ways. Several have dealt with Antarctica, for example, and trying to get the public interested in not simply what's happening in Antarctica, but again, what this prefigures for the future at scale. Mm-hmm. And it's a challenge. It's a challenge to get people to take seriously something that happens invisibly and slowly, not one of the strengths of the human race. So, Jeremy, do you want to talk about what happened next?
Yeah, so first of all, thanks for having me and us, and thanks for doing what you guys have been doing since pandemic started. We've been following this group and your work, both academically and of course your outreach work here. So we're just thrilled to be a part of this, and thanks. Chris, I think I'd like to share my screen and just show a couple of visuals for those that aren't that familiar with VR, and to kind of ground us in some visuals. So I'm going to do that now. And it doesn't, oh, there we go.
Wow.
Okay, are we together here? Seeing the
We're
screen?
good.
Okay. You'd think I'd be quicker at that. I'm still working on the agility to get the motor memory of the the Zoom to PowerPoint share. So here is, this is Kristy's work, and Kristy and her colleagues, and this is to the image to the right. Kristy, please immediately jump in as I botch your science, but this is what we call the moonscape. This is right on top of the vents, and this is not how our oceans are going to look in 100 years. That's have to be a lot of natural CO2 to get there, but it gives you a sense of what happens when you have this much CO2 in the water. You've got lots of algae and no coral, and obviously to the left is a zone when you're on the rocky reef outside of near the vents are. So Kristy just described this, her pioneering work here. I just wanted to get some visuals that's from her group. These are actual photos that she and her colleagues have taken. What we did is we began an undertaking that took at least 2 years on the content building, where we combined VR folks from my lab, educational technologists, we worked with Roy P., and then marine scientists, we worked with Kristy and her colleague, Fiona McKelly. And the first thing I want to flag is, as you're building content in immersive VR, it's critical to have all three. You've got to have intense expertise in how VR works, what makes things feel good in VR, makes them effective in VR. You have to have domain specialists in the thing you're trying to build, in this instance, marine science, and you have to have educational technology at play, because there's Chris, as you know, and as all of our hosts here know, it's you can't just build something and not know how it matches onto learning affordances. So you have to have all three. And the three groups, we probably spent, I want to say 7 or 8 months before we put our fingers to a keyboard to do any coding. The storyboard itself took a long time and a lot of just negotiation and deliberation and conflict. And I say that in a good way, of just really, let's make something that we know is going to feel good in VR. And what does that mean? It means, well, in VR, what makes VR special, you get to turn your head, you get to walk around, you get to use your hands. And what are the things that are going to feel special there? On the marine science side, there's I would say this project took an extra 6 months, because we would send it off to our computer graphics colleagues, and they would produce something that came back that looked like Finding Nemo, and we'd have to break it to them. The Mediterranean doesn't really look like that. It's not chock full of all these tropical fish. And so we really spent a lot of time making sure that the sea life was accurate, that you're not encountering species that wouldn't be proximate to each other, that we're really modeling in the healthy zone, things that look the right way. And then, of course, working with Roy P. and his group, really thinking about the length of it, thinking about how interactive you need to make it. And it took a funding from the Gordon Betty Moore Foundation and thousands and thousands of person hours from our group to get this done. Just to give you a sense of what happens in it, there's a number of scenes. I'm just sampling a few of them here. I just wanted to highlight things that both Kristy and Chris said in the intro. We want to show cause and effect. So we take the user through their daily lives, and for example, there's your car, and you actually have to reach down physically with your hand and touch the exhaust pipe. When you do, you get flooded by these CO2 molecules that all come up and fly around you. And then you're transported to the ocean, and you see the same molecules that emerge from the city. We're in the middle panel here now. And then you just really get a sense of the scale of the CO2, and they all fall into the sea, so that this invisible process becomes incredibly immersive and pervasive, and you get a sense of the scale. And then you go through the healthy reef, and you do a species count. You're doing all the types of things that Kristy does when she's underwater. You set a transform, and you count the number of sea snails and other things, and you do that as a scientist. And then in the right-hand panel, when you get transported to the acidified zone that simulates what the oceans are going to look like at 2100, you see that all the life and the diversity is gone. It's mostly algae. You actually hold a sea snail in your hand, and you can see how it hadn't gotten calcium for its shell, and it's all decimated. And the experience lasts about 9 minutes. It's very interactive. It's free. If anybody wants to download it, you go to my lab's website, and it's free to download. You need to have some kind of PC-based VR, meaning it doesn't work on standalone VR, things like the Oculus Quest or the Pico Neo. You have to have a PC that connects to goggles, but I do hope that some of you download it and it's free. And Anna is going to talk a lot about her science, and she's an educational technologist, educational psychologist. But I want to talk about a few things. And so this premiered at the 2016 Tribeca Film Festival. Tribeca has a wing dedicated to VR that's been going since 2015, and we've been there since 2015. This premiered as a film, a VR film, and it ran for 8 days for about 9 hours a day. And we had a line of 200 adults for 9 hours a day, people waiting, sometimes in some cases hours in order to do this. And you simply don't get that for a chemistry textbook. I mean, a lot of this is you're moving molecules around with your hand. You're looking at snails. It's not as if you're riding whales in this demo. You're doing, the science that otherwise might seem a bit mundane, and it really affects motivation. I'm not going to talk about efficacy because Anna's going to really hone in on that. She's a pioneer that does a lot of great work in classrooms, so I won't talk too much about that. I want to talk about scale, though. This current state of virtual reality is there's not a ton of great content out there. Education-wise, there's some nice games, but when you're looking at good educational content, there's a lot of smart people trying, but there's not a ton of work out there that really fit in the goggles. And so what you're seeing here is a map of the amount of countries that have downloaded and installed this particular demo, the Stanford Ocean Acidification Experience, because we can track that off of Steam and other places. And at this point, we are over 100 nations, over half the planet have used this and installed it. I can honestly say that there's hundreds of thousands of people, and that's a very conservative estimate, that now know about what ocean acidification is. And the reason they know is because of this VR demo. I mean, you can try this at home if you're at a cocktail party or a dinner, a Zoom, whatever your coffee Zoom meeting is. Ask the other folks if they know what, quote, ocean acidification is. I still find that about 9 out of 10 adults don't know what it is. And so as a way of bringing awareness, it's been really effective. I'll embarrass Kristy by showing a photo of her wearing those VR goggles. This is at the US Senate. We did a briefing where we had senators come through, congresswomen and congressmen, more important, their staffers. And VR it's got this a shininess to it where you can actually get people who otherwise wouldn't want to hear about the thing you're talking about and get them inside the goggles. And we've done a few events like this in high profile places where we really get lawmakers a firsthand virtual experience with content. And at that point, I'm going to pause and turn over to Anna, because Chris, I know we don't want to turn this into a lecture, but I just wanted to give people a sense of what the experience was and the kind of scale of how we're using it.
And before you jump in, I just have a couple comments, and then Kurt or Young may have a question. But I do a lot of less immersive educational experiences with my colleagues. They're interactive, but they're through the monitor. They're not the kind of embodied full immersion that Jeremy's work typically has. And it makes a difference. My younger daughter is a junior at Smith College in engineering, and she's very excited about oceans. She's been watching a series called Drain the Oceans, where you get to see what's on the bottom when you simulate draining the ocean. And these television documentaries about oceans are great in terms of the science, but you feel detached. You're sitting in your living room and you feel detached from it somehow. And I haven't built an oceans thing that's through the monitor, and I think you'd feel less detached, but you're not going to feel the way that you feel if you get inside of the ocean acidification experience. And I think that matters, because if we want people to change their behavior, it has to be something that really hits them, not just intellectually, but it has to hit them emotionally, and it has to hit them almost physically. So I don't know, Jeremy, whether you would agree with that, but I think beyond the novelty effect, which is valuable in itself, that there's something about the direct embodied experience that makes a difference.
Yeah, so I could talk literally for hours about this. And first off, all of us in my lab are inspired by the work that you do, and as you know, we use your simulations and use it as a basis. In my mind, what makes VR special is you're activating the sensory motor cortex, and you don't have to guess about that. It's kind of a fancy way of saying you're actually moving your body, right? And so there's no you're doing stuff. It's you talk about constructive learning. You're actually moving around and you're grabbing animals and getting haptic feedback and smacking molecules around to actually see what happens when CO2 hit H2O, and you're doing stuff. And so in that sense, we know it's a bit different. However, it's hard to do VR for more than 20 minutes. We've got a 20-minute rule for the goggles in my lab. And you know, what makes your work, one of the many things that makes it effective is that you can build a day's curriculum around it, and you can do it for a while. And VR is going to be quite some time until it's perceptually easy enough that we can do it for hours. And so the home run in my mind is doing the work that you do, which is building this curriculum where it's really, you learn about the system, right? And you learn all about causality through trial and error and organic experience. But every once in a while, you take a field trip from your field trip. You take an immersive field trip and you put the goggles on. And I'm not lobbying that the entire curriculum should get stuffed in the goggles. I think that's a bad idea, and I like combining them.
So Jeremy, thanks. That's fascinating to me. I remember probably about 15 years ago, I was at the Michigan State University, and so there was a guy came to build this kind of things. And I've been reading recently about the development of VR. I'm really just curious from you, has nothing to do with your, sorry, Kristy, your wonderful acidification. I was just curious about where is VR now in terms of accessibility? Just in terms of, you know, because you were commenting that there's not enough resources in education yet. So where is it now? Where can we expect to have that in classrooms, schools in 5-10 years?
But so there's two ways to think about accessibility. One is cost, and the other is for people that aren't able in the same way that others are. And in terms of cost, you know, this summer and next fall, I'm teaching a big class that it's about VR at Stanford, and we've convinced Stanford to buy a pair of goggles for each student. And that sounds extraordinary until you do the math. Right now, you can buy the Oculus Quest for $299. We're going to use it for both classes, so that we're now at $150 per student. And in terms of a university spending money per student, that's not outlandish to spend $150 per course per student. So now I know that's still expensive. We're, in my opinion, for the next 2 or 3 years, we're still going to think of VR as something you go to the library and check out, not like a notebook that every student gets. But you know, when you think about $299, you are getting to you know, far less than a laptop, and you're getting to the realm. In terms of accessibility and other issues, I would say that the VR community is starting to think a lot more about it. For example, what happens if you can't use both your hands well, or obviously issues of vision and hearing, but not enough work's being done there. I think we're a bit behind on that, but I think you're starting to see a new energy there.
Thank you. Kurt, go for it.
Okay, so what are 2 or 3 of the most significant design challenges you have, and what are 2 or 3 of the most significant use challenges you have?
Okay, design challenges. Everybody has to have some physical space, right? So in my opinion, VR is spectacular when you get to walk around a little bit, when you get to, you know, move your body and grab things. And so one of the challenges that when we first put the Stanford Ocean acidification on Steam, we released it free to the world, and you know, we were so excited about this, right? Like, it was we'd built this amazing thing, and some of the first reviews we got on Steam were very angry people whose rooms weren't big enough. In one scene, you've got to go and find all these snails, and the scene doesn't really work if you can't get to the snails. And they had a 2-meter square was their room, and they couldn't get to any of the snails. And so you have to think about how you're handling the space issue. On the design side itself, what I see the most in educational technology, and I'm yelling at myself here more, as much as anyone, is we tend to give somebody a beautiful visual scene and then talk at them. In other words, we lay narration on top of a VR scene, and it's just not the right way to do the job. But it's super hard. It's one of those things when you're being a critic, it's so easy to yell at folks for it. And when you're building the content, it's maddeningly difficult not just to throw narration on top of a beautiful visual scene. So I would say those are two. And then the second question was
on use. So we got design and then use.
oh, so on use, one of my non-academic lives, I've co-founded a company called Striver, and we use VR to train athletes and now employees at companies around the world. And when we work with the National Football League and other leagues, you know.
Oh, you did the football one. I've read about that.
Yeah, it started as a Stanford master's thesis where we worked with the Stanford team, and we quickly started working with all these NFL teams. And you'd have these teams where they're paying a substantial amount of money for a VR system that we know improves decision making, reduces reaction time, and for a lot of teams, it would sit there collecting dust. And that is a metaphor for all use cases that I know of. When you give somebody a pair of goggles and the content can be incredible, getting people to use it, there's a lot of friction. Even with the Pico Neo 2 and the Oculus Quest, which are really good pairs of goggles, and you put them on, everything works. It's really hard to get people to do that. So I would say use in general is a challenge in getting people to use that. The other thing to think about is, and I believe Anna's going to talk a little bit about this, is there's been a paucity of work that figures out how and when the VR portion fits into a curriculum. Right. So when COVID happened, when shelter in place happened last March, I thought as a parent of a 9 and 6-year-old, I was going to be in great shape, because in addition to all the Zooming, I'm going to get my kids in my goggles. I've got many pairs of goggles laying around now, and we're going to get to do a lot of outside education. And what I quickly found is A, there wasn't much content that was suitable for elementary school kids, and B, when you did find it, what was missing was the thing that you would do to then teach them what's going on, right? So it's you can't just stick someone in VR and not talk about it and not have some exercises and follow up. And so the use challenge that I see a lot is people aren't thinking about the outside VR curriculum.
So Anna, I want to toss it to you, because it's incredibly difficult to do research in VR for the implementation reasons that Jeremy described, and yet you have one of the few really strong studies in this area. So please tell us about this.
Yeah, sure. So first, thank you, Chris, for the invitation to share some of our work here. And when I landed in the lab 3 years ago, I was also so curious about, how VR would be used in education, how this immersion would work, for learning, for behavior change, and so on. And I can't forget the first time I went through SOA and this, amazing work from Kristy. And so we first thought how we could, use this good content, because we couldn't find anything else good as that for learning, and to bring that to classrooms, bring that to students. And then checking all the literature, because as a PhD student, that's what we do. We check a lot of the literature. And we found that, especially regarding to design, there was a lack of literature on that. So how would some aspects of VR would associate with learning, would associate, with concern about the ocean health or about self-efficacy? That's an important concept that we have in education, where kids and students, they feel that they are able to learn. So we decided to run this large study. It's a field study. We developed 16 different versions of SOA, considering 4 main variables. So for example, we have conditions where participants will experience VR standing and moving around, having this full experience, of VR. And some of them would have VR seated, using lasers, to select objects and so on. We have conditions where participants would hear a female narration or a male narration, and we would like to check if there is any difference on how much they would trust the information just because of this difference. And also, we wanted to check if hearing about climate change would be different than listening about ocean acidification, and that if that would associate with all these variables that we are looking at. And finally, we also would like to check if having this segmentation, as Jeremy mentioned, if we have the narration with these beautiful visuals and we do not have enough time to think about, we are just, listening. If I have a condition where I have these pauses, where I can think about it, would that associate with learning, with self-efficacy, and so on? So we created the 16 different versions, and along with Geraldine Fauville, that was a postdoc researcher at the lab at that time, we reached out to several study sites, and then we have dozens of them. Now we have study sites in US, we have in Canada, we have in Europe, because we are targeting a large and diverse population. So this is an ongoing study that we are still working on, and we are interested on understanding better how the design of VR will impact all this learning and self-efficacy, trust, and pro-environmental behavior as well. And besides that, so we run also another field study where we took several headsets and went to schools. So this was one of the first large-scale field study where we had more than 200 students going in VR. And we had middle school students learning about climate change and ocean acidification using 360 video in VR or using a computer. So we used two pieces from the lab, the coral compass and the crystal reef, and we compared how much they learned, and those pieces, they tap into conceptual learning, and also how much it would affect their self-efficacy perception. And we found that at the first study that we had a significant difference between those groups for self-efficacy. So meaning that after having VR experience, participants reported a higher self-efficacy than participants that had the exactly same experience but using a computer monitor. And then we decided to run a second study, and we target the same population, middle school female students, and we used the same video, coral compass and crystal reef, but this time we had a larger sample, and we evaluated, we took a post long-term measure, so 6 weeks after having the experience. We wanted to check, how much those differences would be sustained or not 6 weeks after. And then we had similar results for the immediate measure. So right after having the VR experience, participants in VR reported higher self-efficacy than participants that had the desktop version of it. And 6 weeks after, the results were not significant different. So we had kind of the same results for both groups, both for learning and for self-efficacy, indicating for us that this result is short-termed. And then and for future studies, what we want to check is that if we have, more often experiences, we have repeated sessions, would that impact long-term results or not? So those are future studies that we are looking at as well.
Well, I just have to say that as a researcher, I know how hard it is to do what you just described. And I'm actually part of a team that's writing a proposal to NSF to move the field towards component-based research, which is really the kind of research that you're doing, is not to treat an intervention as a single unitary thing, but to look at its various dimensions and try to sort out what each one of them means. So it's really impressive. So I have one question, and then I want to go back to Kristy. Some of my research, I know what the outcome's going to be, but I need to do the research because other people aren't going to believe it if I don't provide the evidence. And I'm not saying that because I have a crystal ball. I'm saying that because if you're able to deliver deeper content effectively, then yeah, you're going to get deeper content for the outcomes, right? I mean, it's not rocket science. If it's active learning, yeah, it's going to be more engaging. Nothing surprising about that, but still you have to do the work. But what I want to ask is there anything in all that mix of results that you found surprising, and that you had to think a bit about what was going on?
Mm-hmm. Yeah, so for me, what is surprising is that they had exactly the same experience. The only difference was just having the headset, and it impacted significantly their self-efficacy. So that's, for me, it's still something I'm looking for answers about it, because we know that they are more engaged, that they are more excited about it, but what exactly in VR that is tapping into that, that's allowing them to feel more, that they are able to learn, feel more confident about solving complex problems just because they are wearing goggles. So that's something that we are looking for answers still, right?
So Kristy, I'm going to confess my ignorance here, but I'm used to doing that, so I'm not embarrassed about it. I care a lot about the future of the climate and environment and human race, and so I've been trying to understand all of these different things that are interacting to shape what's happening to the world, and it's frankly puzzling. I watched a documentary with my daughter a couple days ago. I forget the exact title, but basically what it said is, if you want to help the oceans, don't eat any seafood, because the fishing industry is destroying the oceans. So, and I know I'm not supposed to eat any meat, because the meat is too high up in the food chain, and so it uses a bunch of carbon, and I'm not really supposed to go driving around in my car eating vegetables, because that's generating carbon dioxide. So, I mean, I think there's a problem with messaging, in a sense. What really is the right message that we want to send to people if they go through these experiences and they say, I care, but I keep getting
Looks like we lost Chris for 10 or 15 seconds here.
Yeah, my guess
But I
is
think he's
come
got
back.
the question asked, so any of you can jump in.
Yeah.
I think he was getting Kristy or Anna want to jump in first, either one of you.
Sure. I mean, I think he was getting at, what is the message that we want people to get from the ocean acidification experience, or any of these large scale environmental problems. I think that there's an awareness piece that is still missing about some of the ocean issues. And I can't remember, Jeremy was just saying, there's a huge amount of people who just don't even know it's happening. And it's so hard when you come to the coast and you see this beautiful blue ocean to understand what is happening underneath the ocean. So I think that there's just there is an awareness piece that I think we are still working on with ocean issues, that there's a problem here that we need to start paying attention to. And then, any talk I give in the ocean acidification experience at Stanford, what I want people to take away is that there is something that you can do about it. That this problem, although it's global in scale and is very complex, is driven by carbon dioxide concentrations. And those carbon dioxide concentrations are coming from human activity. Now, we all can think about the ways that we can reduce our carbon dioxide emissions. So you mentioned some of them, Chris, about choosing the foods we eat and how we travel and all of that. And so I think there's some awareness pieces there, but it's also large scale political action that needs to happen. And so being engaged and understanding what our options are, and talking to your representatives if you care about it. In terms of I'll just add one more little piece, to all, I don't think it's don't eat anything from the sea and don't drive anywhere to get your vegetables, but I do think being hyper local is pretty useful. So if you live by the sea, it's okay to eat things out of the ocean. The ocean still has lots of marine life in it, and there are sustainable fisheries all over the place. But it'd be better if you got your fish locally, and it'd be better if you got your vegetables locally, because there's a lot of carbon associated with shipping things around in this world. So I'm sure Jeremy and Anna have thoughts about that as well, what you want people to get from the ocean acidification experience.
The only thing I'll add to that is we're at the point now where we have to think about climate change adaptation. So, while we simultaneously try to reduce CO2 and solve the problem, we have to think about, now that it's happening, how can we manage it? And I think there's a separate policy piece to that.
So I have a question for any one of you. Probably mostly it would be Anna or Jeremy, since you guys were building this. So when you showed me the map of download, I was very impressed. So a lot of, are you aware of a global network or people who is doing VR in education? Can you share with us, some of the people, and mostly VR in it, because you hear a lot about these things, but from what you were describing, it's so hard to create. It costs so much money to build in all these things. So can you share with us, if you want to know who is doing what in these areas?
Yeah, so I can certainly direct you to places where there's these folks congregate. I helped form the Global Future Council for the World Economic Forum on VR, and we took extreme care to, as the WEF always does, to have international representation. And so on the creating content side, you're right. It's you're not going to see as many places contributing to content creation. However, it doesn't mean that you can't be downloading and using, again, the hardware now. If you're talking about owning a laptop, you can now talk about having VR for actually less money there. So there's a surprisingly large amount. And Anna, do you know, is there a website you would recommend people go to kind of get a sense of the educational immersive VR world?
So there is the Immersive Learning Research Network, where they have very good information about what has been doing this in the educational world for VR.
Yeah.
I've been involved with iLearn as well for a long time. And what's interesting about the pandemic, it's one of the silver linings, is that you can go to a conference now much more cheaply than used to be the case.
Yeah.
And they hold their conferences in a virtual world called Verbella, which is sort of a third generation Second Life-like environment. And it's not that expensive, and you don't have a hotel, and you don't have to travel, and you can be at a conference. And so it's actually made communication among like-minded people a lot easier.
Well, I was at iLearn physically in Portugal, and had a chance to keynote it 3.5 years ago, and had a fabulous time. I wouldn't give up that for anything. But it was one of my 2 remaining questions. I'm sorry, Kristy, go ahead and I'll ask my 2 questions.
I was just chiming in that it's also less carbon, less expensive and less carbon.
Definitely so, but you still like to meet. Anyhow, so you got an educational technologist involved. You mentioned Roy P., whose work I've tracked since grad school, and he's a good friend of mine. And you talk about subject matter experts and other media people that are involved in all of this. How do you get all the personnel that might be involved in a VR or AR project to form a community around different events that you might go to as a team? And how do you decide which dissemination outlets that you might want to go with? Because one form of dissemination might favor one member of the team and their typical colleagues that they might want to be talking to, and another dissemination outlet might be more, let's say, from education space or educational psychology space, or so what have you found to be useful outlets in terms of conferences and journals and events like iLearn that have been advantageous for the whole team?
Yeah, so there's many questions embedded in your question, and I like them all. I'm starting on the one which is, for this particular piece, Roy, myself, Theo, and Kristy, somebody's got to be the one who makes ultimate decisions on stuff. And I kind of viewed myself as a mediator in many ways in this, between all the parties. And of course, I would put my foot down every once in a while on a VR side, meaning can't be more than N minutes. It's got to have some movement. But this isn't going to work for everybody, but this was an instance in which everybody was aligned, in the sense that, Kristy and Theo, it'd be cool for them if more people got to hear about ocean acidification. For me, I wanted to study something environmental. To be honest, as our process went on, it wasn't as if I knew much about OA or cared about OA more than I cared about deforestation. It was just, I happened to find two amazing experts and wanted to work with them on it. So I do hear you that I guess in our triad, and Kristy, you can correct me if I'm wrong here, I think I had more invested in this temporally, and therefore I kind of chose what journals and what studies we go in, just because this but I don't think that that's always the case in terms of great places and conferences. The VR scene is fragmented, and moreover, the way you can use VR is fragmented. So we've built this this piece that I mentioned earlier. It works on PC, personal computer based VR. It will not run on a Pico Neo or an Oculus Quest because it's too processing intensive, and there's communities forming around these standalone devices where they don't get to try this, and there's challenges there. In terms of journals and conferences, I would say Anna and I have struggled when we try to submit our work to straight up education journals. Their reviewers don't love VR, it turns out. And Chris, I know that that's a problem you've been dealing with for quite some time. I like Technology, Mind, and Behavior, a new psych journal. They're really excited about VR. I've been following in the past few years. Rich Mayer's a mentor of mine and a colleague, and he and his group have gotten really active in the last couple of years, and I've been following them and where they submit. But I wouldn't say there's a great answer between super high impact journal and loving VR research. I don't think there's that Venn diagram sweet spot exists.
Before I ask my other question, does Anna or Kristy want to jump in there on what they? I also follow Rich Mayer's work. He's a good friend, and I can't keep up with him. No one can. This whole field has evolved, but it continues to evolve, and it continues to excite. And that's just the thing. That every year we hear that this is going to be the year of VR. Or the year of AR. And the same thing was true of ebooks. And it wasn't until 2009 when all of a sudden we hit Malcolm Gladwell's tipping point, right? And I wonder, in your vision of things, you're heavily in the field, when do you think we're going to hit the tipping point? Do you think we already have? And what's going to need to put in place for that tipping point to occur? Is it cost? Is it a familiarity? Is it federal support? Is it international exchanges? What's going to have to happen?
Yeah, Anna, do you mind describing your experience, A, with the classrooms, and B, with all of the museums and the other organizations you've negotiated with to have them install this?
Yeah, sure, Jeremy. So some challenges that we faced was, for example, bringing VR to the classrooms. The teachers, they are not familiar with the equipment yet. So we needed to give a huge help with them, how to handle it. And we were handling the equipment most of the time. So that was the first thing. But they were very interested on that. And, we keep in contact since nowadays, because they would like to have more experience in VR in their classrooms. The second thing, and that's related to, translations. So we used to have mostly English content of VR because we have most, of course, our content is in English, but we now have several translations, for SOA, we have for Coral Compass, Crystal Reef, because we want to reach out to people from a diverse population. So that was another challenge that we faced. And the second is just that the teachers, they don't know how to integrate VR to the curriculum yet. So there is no work on that with the schools, for example. So it all would require training time for the teachers that are already overloaded with other things, So I believe that's something that is changing, and the pandemic changed it a lot, and it will increase in the future, the use of VR there, because they have been reaching out to us so often, how they can bring more interesting experiences to the students, especially now that they are home.
I think there is a kind of tipping point that is happening that I see with my graduate students. More and more global South countries are getting into the water with VR because of the kinds of changes that Jeremy has described, and because of the kinds of concerns that Kristy studies and that we're talking about. Tokes Bakari, who is an alumnus of our master's program and who now is a teaching fellow for me in my spring course, is developing a VR and autism intervention and getting a lot of interest. She comes from Africa, and we had an earlier episode where one of the experts was doing VR for girls in Africa. So I think there's a spectrum of immersion, and one of the things that Jeremy said I agree with is completely. You want to navigate up and down the spectrum of immersion. It's not like you want a VR curriculum, even if you have enough VR. It's not like you want a 360 video curriculum just because you have some Google Cardboard. You sometimes you're face to face and you're reflecting. Sometimes you're in a virtual world like an internet game. Sometimes you have your full nervous system engaged in VR, and the design issues involved in doing that are complex, but I think the payoff is potentially very high, and I'm very excited about the Global South involvement.
And also just involvement beyond medicine, business, and the typical areas that we see funding. So 2 days ago, Bill Watson at Purdue, one of my former students, said, we're doing it classroom management. That's what we're working on VR for classroom management. I thought that's great, So
if there's one thing I've learned, I've lived in the Valley for 20 years now, Silicon Valley, and I've learned I'm a lousy futurist, and I cannot predict uptake of technology for the consumer market. So I'm not going to say, I agree with you that far too often have we said, next year it's going to be in your living rooms, and next year it's going to be in your living rooms. But, there's one thing I'm confident of it. Every year, the hardware gets better, the content gets a little better, and the use gets a little bit more pervasive. But I don't think it's going to go whoop. It's going to be a very deformed hockey stick.
So I was reading this book. It talks about called the period of deception. So this technology kind of a period of deception. So we kept talking about how great it is. Then it becomes bad. So then after a while, after that period, new technology develops, boom, it jumps up really quickly. So I was going to ask the three of you guys a question the same. People talk about technology convergence. So it's not one technology that's going to make a big deal, it's just the convergence. It's like AI, our artificial intelligence added to VR, added to maybe kind of cloud computing. So do you see a big movement in that direction? Let's say, VR combined with AI, for example, and all combined with possible human broadcasting through VR. Just do you see any kind of excitement in that area, you guys?
I will say that VR wouldn't be as good as it is today without all sorts of AI on the tracking side and on the rendering side. And, clearly anything today, you want to talk about hype cycles, saying the word AI, neural nets with lots of layers, calling it deep is going to get people excited. So I think VR is where it is today because of AI in a lot of ways.
So we're running out of time, but I have a couple audience questions that I want to make sure that we fit in. One of them is from one of my colleagues who's a research scientist at Harvard, Julian Radu, and he asks, would the learning content relate to long-term effects? So would a more embodied activity, like requiring physical manipulation of chemical molecules, yield stronger long-term effects than maybe trying to learn that used a less embodied activity? What would be your prediction on that?
Anna, do you want to take that?
Yeah, so I believe that with long-term exposure, like having more exposure to VR, we would have a stronger long-term effects of what we are seeing now. Just because we're gonna have this prediction of the novel effect, we are gonna have this boost of, for example, when we talk about self-efficacy, so very more often that could support a more sustained change.
So the other question comes from one of our co-hosts who had a conflict but made it back in time to join the live streaming audience. And he asks, maybe instead of worrying about the teachers, who are in fact a barrier to any type of ed tech that they're not familiar with, going straight to the learners who may be much less reluctant to grab the headset and just go with it without worrying about all the things that we as adults worry about. Do you think that VR is getting to the point that we're going to start to see learner communities, young people authoring reasonable level VR? Any speculations about that?
So yeah, I'd like to combine an answer with the previous question with this one and talk about some work from Fernanda Herrera, who ran a study with about 1,000 learners, informal learners in a museum at the San Jose Tech Museum. And because we had 1,000 subjects in the study, we had enough that we could actually have a pure control. We normally don't have a pure control where you look at outcome measures without any VR, because VR is expensive and hard to do. And we found something puzzling, which is that the treatment group, the VR, it was better than the control, but not by the magnitude that we were used to seeing. What Fernanda then did is she did some analyses inspired by football. And football, coaches will often say, we had a really good practice today, guys. We had a really good practice. And it made us think that just because you're in VR doesn't mean you're doing VR. In other words, putting the goggles on your face doesn't mean that you're being a good learner and actively engaging. And Fernanda computationally went back and found out algorithms to basically figure out if you did it right by analyzing your movement and binned the 700 VR learners into high and low in terms of their physical motion and engagement, and showed that the low movers were equal to controls, meaning if you're not doing VR the right way, picking up the snails and looking at them, then it's equal to not doing it at all. And so I do think you're going to start seeing it in formal learning contexts where learners can engage without the classroom. And I do think movement is critical to the long-term effects there.
So I need to start wrapping things up and prefiguring next week, but I just want to say that, we are ed tech people, and so we've ended up talking a lot about ed tech. But Kristy, I just think the climate work and the preserving the oceans is so important. And we need to find ways to tell that story, and to the leaders as well as just to the general public. And I hope that we can find a lot of ways in the next 10 years or so to be able to do that. But it's very exciting that you're doing that research, and I hope that this episode has given you a good platform for sharing it, and Jeremy and Anna to share your exciting design and research that are helping us to tell that story and helping us to get that message across. So next week is Hosts Reflect Week. We've had quite a string of episodes with exciting people. Every once in a while, we take our heads out of the helmet and kind of look at the sunset and try to reflect about what we're learning from the stream of things. And next week will be an opportunity for us to do that. So we hope you'll tune in and help us with the reflective process. And again, thanks to all three of you, and please keep doing the great work that you're doing.